Right, we're busy with calculus and we're still looking at tangents to a curve, and we are now inspecting when a tangent is perpendicular to one line or whether it is parallel to one line. We've looked at parallel to one line. Now we're going to look at one that is perpendicular to another line. This question asks us calculate the equation of the tangent to the following function that is perpendicular to 8y plus x plus 17. That's not the usual format of a straight line where x is less than 0. So here's a few things that stands out that I need to relook very carefully because I'm not used to this type of format firstly, and secondly I need to look at what and how am I going to go about with the information up here. So let's start firstly with this equation. Now normally if this is the equation, I would assume that this is equal to 0. So I try to write that in standard form first, and then I say y is equal to negative 1 over 8x minus 17 over 8. That is my standard form. Now I've got my gradient is negative 1 over 8. I know I'm talking about perpendicular lines. So if I want the gradient of the tangent, I need to multiply with the reciprocal and the sign must change, or I say the gradient of the tangent is equal to negative 1 divided by the gradient of the line that it is perpendicular to. Because gradient 1 multiplied with gradient 2 must give me a result of negative 1. So gradient 2, the gradient of the tangent, is then 8. So we find now the derivative of the function. So our differentiation rule says my exponent must be multiplied with my coefficient, and after I've done that I need to subtract 1 from my exponent. 3 multiplied by 1 is 3, x squared. 2 multiplied by negative 4, negative 8. 2 minus 1, x to the power of 1. 1 multiplied by negative 3 is negative 3. 1 minus 1 is 0, so x to the power of 0 is 1, so 3 times 1 is 3. Right. So I know my gradient is equal to 8. I substitute in the differentiated value of the function and I simplify. 0 is equal to 3x squared minus 8x minus 11. Factorize and I get the values of x being negative 1 or x is 11 over 3. But remember, x is less than 0. So the only one that is applicable is negative. I can only use negative 1. So I've got my x value. I substitute into the original function. And when I substitute into the original function, I find that f of minus 1 is negative 2. At this point, I have my x value, I have my y value, I have my gradient, which is 8. So I substitute that in the equation y is equal to mx plus c, calculate my c value is 6. So my equation of my tangent to the function at point negative 1 and 2, and negative 2 is 8x plus 6. So what I've done here is the line that it stated. This is that format of this one here. 8y plus x plus 17. This is that guy, right? So this line is perpendicular to. So that means I'm sitting here with a 90-degree angle because it's perpendicular to. So this line, the gradient will be the inverse of this one, the reciprocal of this one, and the sign must change. So 8x plus 6. I must check whether it is a tangent to the function. It touches the function at one point and one point only.